Let's have a look at that identities handout and see if we can decide which supposed identities really are true identities and which are false. There are a couple in here that are false. So as always with these handouts, it's best to pause this video and try the problems for yourself before watching me work through solutions. So number one, cosecant theta times cosine theta equals cotangent theta. So there's not too much to work with here. And so my only idea is write everything in terms of sine and cosine and see what happens. So cosecant is 1 over sine theta. Cosine is, well, cosine is just cosine. And 1 over sine theta times cosine theta is cosine theta over sine theta. And yeah, that's cotangent theta. So we're done. That one wasn't too bad. So this supposed identity really is an identity. Okay, let's look at the next one. Cosine squared theta times 1 plus tangent squared theta equals 1. I don't know, it seems plausible. There's nothing about it that makes me want to try to disprove it instead of prove it. So let's see what we can do. I have a couple ideas for how to start. We could start by distributing the cosine squared or by writing the tangent squared in terms of sine and cosine. Either would be fine, but I don't know. I feel like distributing first. That's just how I feel today. So we get cosine squared theta plus cosine squared theta times tangent squared theta. So cosine squared theta plus, well, now I think there's no way of getting away from dealing with the writing tangent in terms of sines and cosines. So let's go ahead and do that. So cosine squared theta times tangent squared is sine squared theta over cosine squared theta. This is because tangent is sine squared over cosine, sorry, sine theta over cosine theta. But this tangent is squared, and so this squaring hits both of the numerator and denominator. Okay, but look, now these cosine squareds simplify away, and we're left with cosine squared theta plus sine squared theta. And, well, that's 1 because of the Pythagorean identity. So this genuinely is an identity, right? That's what we were supposed to get. So this identity, this supposed identity, is true. Okay, let's move right along. All right, so let's see. Looking at this supposed identity, on the left-hand side, I have a clear idea for what we could do to start out with. We could just start by distributing here. So let's do that and see what happens. We get sine theta plus cosine theta. No, we get sine theta times cosine theta, that's more like it, plus sine theta times cosecant theta is 1 over sine theta. So these simplify, and we get sine theta times cosine theta plus 1. Okay. Well, at this point, I'm not really sure what to do next. And comparing this expression we have with what we're looking for, secant theta, these don't even have the same domain, right? Sine theta times cosine theta plus 1, the domain of that is all real numbers, and secant theta has a bunch of holes and asymptotes and things. So I'm kind of skeptical that these could possibly be equal. So let's check by just plugging in some theta values. So you might start with theta equals 0. For theta equals 0, on the left-hand side here, well, actually, we can't even plug 0 into the left-hand side because cosecant isn't defined as 0. So let's try maybe pi over 4 instead. So for pi over 4, sine of pi over 4 is root 2 over 2. Cosine pi over 4 is root 2 over 2. Cosecant pi over 4 is square root of 2. And we want to know, is that equal to secant pi over 4, which is square root of 2. So let's see. If we distribute here, we get square root of 2 over 2 times square root of 2 over 2 is a half, plus square root of 2 over 2 times root 2 is 1. Is that equal to the square root of 2? No, definitely not, right? 1 plus a half, that's 1.5. And square root of 2 is approximately 1.4. So these aren't the same. So this is not an identity. It's false. It's a lie. Okay. Let's try this one. Okay, it looks complicated. I don't know which side to start with because they look, sort of equal. Just sort of thinking big picture about what pieces these are built out of. Tangent is made out of sines over cosines, and cotangent is made out of cosines over sines, right? So here we have sines over cosines, and here cosines over sines. But, if we multiplied these, things would cancel and we'd just be left with a 1. So maybe what we need to do is somehow multiply this tangent by a cotangent, because that'll make this 1 here show up. So let's try this. 1 plus tangent v over 1 minus tangent v. So my idea was multiply this by cotangent v over cotangent v. Then we're going to have to distribute like this. In the numerator, 1 times cotangent is cotangent, plus tangent times cotangent, that's 1, over, and then in the denominator, 1 times cotangent is cotangent, minus tangent v times cotangent v is 1. And, oh, that's it. We're done. All right, here's the next one. I'm not going to lie, this one is pretty tricky, and I worked it out ahead of time because there are just so many things to try, so many possibilities for things you might multiply by, ways to write it in terms of sine and cosine, things to factor, all sorts of things you could try. So there are so many possibilities that it took me a couple tries to stumble on to the right thing. And for me, what worked out is starting with this left-hand side and writing everything in terms of sine and cosine. So I got secant is 1 over cosine theta, plus tangent is sine theta over cosine theta, over cotangent is cosine theta over sine theta, plus cosine theta. Now in this denominator here, we're going to want to add these two pieces. So let's put them over a common denominator. So this cosine theta, we can multiply by sine theta and divide by sine theta. There we go. All right, now in the numerator and the denominator, we can do our additions. So adding the numerator, we get 1 plus sine theta over cosine theta, over, and now in the denominator, we get cosine theta plus cosine theta sine theta, all over sine theta. All right. It's sort of clumsy to have a denominator in your numerator and a denominator in your denominator. So I rearranged things by, so this 1 plus sine theta, we're going to leave alone. In the denominator, our cosine theta plus cosine theta sine theta, we're going to leave alone. But these denominators I pulled out to the side. So this sine theta is in the denominator of our denominator, so it's really in the numerator. And this cosine is in the denominator of the numerator, so it's really in the denominator. All right. So this piece on the right, sine over cosine, well, that's tangent. So that's looking good. I like having this part here. So this other piece, hopefully it turns into secant somehow. So let's see. Both terms here have a cosine, so let's factor that out in our denominator. The numerator is going to stay the same, 1 plus sine theta, over cosine theta times 1 plus sine theta. And then this piece on the right, this is just tangent theta. And now, look, the 1 plus sine theta, those simplify away, and we get 1 over cosine theta times tangent theta. And that's secant theta times tangent theta. Oh, we did it. What a mess. Okay, let's try the next one. All right, secant theta minus sine theta is equal to sine theta times tangent theta. So usually it's easy to, sums and differences are more complicated than products when it comes to trig functions. So let's start with the left-hand side, secant theta minus sine theta. And I don't know, write everything in terms of sine and cosine, I guess. So 1 over cosine theta minus sine theta. To subtract these, we're going to need a common denominator. So let's multiply and divide this piece by cosine theta. Okay, so now we can do the subtraction. 1 minus sine theta over cosine theta. On the right-hand side, right, sine theta times tangent theta, that's sine theta times tangent theta is sine over cosine. So this would be sine squared theta over cosine theta. And I don't know, looking at these two, I don't really see these ever being equal to each other. So I kind of suspect that that this supposed identity is actually false. So let's try plugging in some theta values. How about theta equals 0? For theta equals 0 on the left-hand side, secant of 0 is 1 minus sine of 0 is 0. Now we are going to check if this is equal to the right-hand side. On the right-hand side, sine of 0 is 0, and tangent of 0 is also 0. So no, these aren't equal to each other. So this isn't a real identity. False. Okay, last one. Second to last one. This is another one that I found pretty tricky. I had to stumble around and try several different things before I stumbled on one thing that worked. So for me, it looks like the left-hand side is the more complicated side. So let's start with that. Sine theta minus cosine theta plus 1 over sine theta plus cosine theta minus 1. And it really isn't clear how to start here. And one of the sort of last resort tricks that you can use is to make some sine squareds and cosine squareds show up by multiplying the numerator and denominator here by some sort of conjugate to get a difference of squares type thing to show up. And I had to try a couple different things here before I figured out the right combination of pluses and minuses that worked. And what I got was sine theta plus cosine theta plus 1. So multiplying the numerator and denominator by this. Okay, so you can see this is sort of a conjugate of the numerator because it's the same as the numerator, but this sign is switched. And it's sort of a conjugate for the denominator as well, because it's the same as the denominator, except that sign is switched. Okay. So, unfortunately, multiplying by this makes a real mess. We have to just multiply all of this stuff out. So sine times sine is sine squared. Sine times cosine is sine theta cosine theta. Okay, sine times 1 is sine. Okay, that's it for this first piece. So now minus cosine times each of these. So minus cosine times minus sine is minus sine theta cosine theta. Minus cosine times plus cosine is minus cosine squared theta. And then minus cosine times 1 is minus cosine. And now, so that's it for the cosines. Now I have to distribute this 1. So 1 times sine is sine theta. 1 times cosine is plus cosine theta. This needs a plus right here. And then 1 times 1 is plus 1. Okay, now before we go any further, I'm going to simplify some things. This sine theta cosine theta cancels that. And then here we have a plus cosine theta and a minus cosine theta. So those all cancel. And, you know, actually, here we have a 1 minus cosine squared. That's sine squared theta by a Pythagorean identity. But, so we're going to be able to combine these two. Okay. Now for our denominator. It's going to be a similar thing, but the plus and minus signs are going to be different. So sine theta times sine theta is sine squared theta. Sine times cosine is plus sine theta cosine theta. Sine times 1 is sine theta. Cosine times sine is plus sine theta cosine theta. Cosine times cosine is plus cosine squared theta. Cosine times 1 is plus cosine theta. And then now distribute this minus 1. Minus sine theta, and then minus cosine theta, and then minus 1. Okay, we'll come back to this one. I need more room. Okay, let's see. In the numerator, we have 2 sine squared. And then we have 2 sine, so plus 2 sine theta. And that was it. Everything else we've already accounted for. Now in the denominator, we have a sine squared and a cosine squared. Those add up to 1, but here's a minus 1, so these all cancel. All right, we have a plus sign and a minus sign, so those cancel, and a minus cosine and a plus cosine. So in the denominator, we're just left with 2 times sine theta times cosine theta, right? And, well, in the numerator, we can factor out a 2 sine theta. So 2 sine theta times sine theta plus 1 all over 2 sine theta cosine theta. But then the 2 sine thetas cancel, and you get sine theta plus 1 over cosine theta. And that is what we wanted. So finally, if you look at where we started, sine theta plus 1 over cosine theta is what we were looking for. So this really is an identity, but this is maybe one of the hardest ones I could have possibly given you. Okay, last identity here. So on this one, I think there's no doubt as to which side is the more complicated side. It's the left side, so let's start with that. And it seems like there's nothing to do to start with except just distribute everything, right? We have these squares. We can multiply out the squaring. So on this first one squared, so that's a squared sine squared theta plus twice the product of these two pieces. So 2ab sine theta cosine theta, and then plus the square of the second one. So b squared cosine squared theta. All right, now we can square the second piece. So first piece squared, a squared cosine squared theta, minus twice the product, so 2ab sine theta cosine theta, plus the second piece squared, so b squared cosine squared theta. All right, right off the bat, some nice stuff happens. These big middle pieces are gone. And we have lots of trig functions that are squared, so probably the Pythagorean identities are going to come into play. So let's group together these parts because it has a sine squared and a cosine squared, and they have an a squared in common, and then we'll group the parts with the b squareds as well. So a squared sine squared theta plus a squared cosine squared theta plus, and now for the part with the b's, b squared cosine squared theta plus, oh, I made a mistake. This cosine right here shouldn't be cosine. This should be sine. Okay, so b squared sine squared theta. Okay, now for these first two pieces, they have an a squared in common, so let's factor out the a squared. A squared times sine squared theta plus cosine squared theta plus, and then the second two pieces have a b squared in common, times cosine squared theta plus sine squared theta. But then the Pythagorean identity comes to the rescue. This is a squared times 1. This entire chunk in parentheses is just 1. So a squared times 1 plus b squared times 1. And that's what we were supposed to get, a squared plus b squared. So this is really an identity.